Hello, this is my project and presentation of that said project um, on the uniformity of operations. Um, and I wanted to start off with or addition because all of our subsequent lessons and the things that we'll look at will also have addition within them. So it seemed like the correct one to start off with. So in order to do this, all we're gonna be doing is combining like terms. And what I mean by like terms is that we're going to be combining the things that are within each column or which are within each place value. So you could see here in the number 421, I have 1 in the 1 spot, 2 in the 10 spot, and 4 in the 100 spot. And you could do the same thing, 2 in the hundreds for 264, 6 in the tens, 4 in the ones. So in order to make the equation correct, or just to add in general, we want to keep our ones with our ones. So I kind of drew this graph to illustrate that we would just be just dropping it straight down and combining like terms. So we have 1 plus 4 equals 5. We have 2 plus our 6 equals 8. And see how we're keeping them in the same columns, so we keep them with each other. And then we have in our 100 spot 2, or 2 plus 4, 4 plus 2 is 6. So we can go ahead and take these kind of bad boys away, and we have the exact same uh, relation. See, our 6 is with our hundreds. This is with our 8s, or our 8 was with our 10s, and our 5 is with our 1s. All we did was just drop them down and combine like terms, which means we just combined 1s and 1s, 10s and 10s, hundreds and hundreds. For our next section, I wanted to look at adding fractions with unlike denominators. So you can see here we have 2/15, 2/15, or 3/10, 3/10. And in order to add these, we have to make sure our denominators and our numerators get added together or are combined, because they are also both like terms. See how this number is on the bottom, that number is on the bottom. They have the same relation within the equation, so they are going to be the ones that will be combined. But in order to add uh, equations like this, I have to make sure that both my denominators are the same number. And if I wanted to do that, I have to find a factor that goes both into 15 and 30. So I drew this little graph out here. So for my tens, I have, it goes by 10, 20, 30, 40, and I could go on exponentially. Or for 15, I have 15, 30, 45, and 60. Well, I can see here that immediately I have a 30 and a 30. So I can make both of these numbers 30. I just have to get there. And so what times 15 equals 30? I can just come back over to my thing and see, well, I just counted 15 twice, so 15 times 2 would be 30. So we add 2 and 2, and then I do the same thing with 10, but I go over 3 spaces instead, so a 3 and a 3. And then all I have to do is just multiply the numerators and the denominators to get my answers. Then I can plug in and we'll have the same denominator. Then we can finally solve this equation. So we're going to have 30 here on the bottom, and 2 times 2 is 4. Then we're going to have, let's just go ahead and plug that into the bottom. Then we're going to have 3 times 3 is 9, and 10 times 3 is also 30. So plug that into the new equation. Now, once we have denominators that are the same, all we have to do is bounce our denominator. So we'll bounce our denominator, and our numerator will get added together. So see, it's a 30, and it just bounces over. Oh, it's also a 30. We bounce it over to the answer. Well, if that was a 30 and this was a 30, now that I made them 30, and they're the same denominators, well, our answer has to be a 30. So we'll go ahead and put the 30 there, And then all I have to look now is at the top, and I have 4 plus 9, and I know that one is just 13. So 13/30ths would be our answer. So for our next one, we're going to add mixed numbers together. Now, in the case of mixed numbers, I want to keep the same thing like we've been talking. I want to keep the whole numbers together, and I want to keep my fractions together because it just is going to make this process a lot more simple. It's going to make it a lot more straightforward instead of making it like an improper fraction. So what I can do is I've outlined, see here, the 4 is a whole number because it's off to the left side of the fraction. It is a whole number by itself. 8 is a whole number by itself. And then we have 2 fractions. So so we kind of know if our question looks like this, our answer is going to look something like the same thing. So it's going to have a whole number followed by a fraction. And what we can do in this instance is just go ahead and add these like terms to get it out of the way. 8 plus 4 or 4 plus 8 is going to be 12. So super easy. We'll just add the whole numbers, and now our equation just kind of looks like the equation we just did. It is a fraction plus another fraction. We'll just hold off on the 12 for right now. We'll just keep that and drop it back into our answer later. So I kind of wrote our multiples of 6 and 5, and I come in here and find something that correlates with both 5 and 6. It would be, well, you could do this mental arithmetic where you could just know it or draw this out, but it's going to be 30. So we'll put 30 here, 30 here. So what times 6 equals 30? Well, I can just go over and count 1, 2, 3, 4, 5. 5. And if I change the denominator, I have to also change the numerator. So I'm going to also multiply the top by 5. Then I can do 6 and 6, right? So let's do this equation first. We have 6 times 5 is our 30, which was our desired number that we wanted. And then 1 times 5, 5. And then for our next one, we do 5 times 6, which gets us our 30. See down here, we just counted over. 1, 2, 3, 4, 5, 6. 5 times 6, 30. We'll do 6 times 3. Oh, well, I already actually have that out here as 18. So now our equation looks a little, instead of looking like that, looks like this. Now we have denominators that are exactly the same. We have 5 plus, we'll make it real big, but we have 5 plus this plus that. And like we did with the last one, well, now our denominators are correct. All we have to do, or correct, or the same number, now we can bounce them and add the top. So see, bounces, it's the same number, we'll bounce to the next one. It'll be the same number, 30. And we add the numerator, 18 plus 5, I believe is 23. So our answer is 23/30ths. And I could go further and try to simplify this, but I know that nothing is going to go into either one of them because I've checked it 4 times. So, okay. So now we're going to do multi-digit decimal numbers. It's pretty simple, pretty straightforward. Like we did for the first problem, we're going to keep like terms together. So you can see up on the board, I have the 10th spot, the 1 spot, we have a decimal column, we have a 10ths column, we have a 100ths column, and a 1000ths column. I drew these lines to illustrate that we want to keep these numbers in the same columns because, like I discussed before, we want to just combine like terms in the things that are in the exact same place value, the numbers in the same place value holders. Yes. And so for our thousands, we just keep these numbers together all the way down. And all we have to do is drop that decimal down. If we line the decimals up, we always want to make sure our decimals are lined up for addition, subtraction. Then all we have to do is just add these bad boys together. We got 5 plus that is 8. We have 13. We will do 1 plus 0 is just 1. Plus 2 is 3. We drop our decimal down because that's in a column of its own. We lined them up. It needs to drop all the way down because in order to get our correct answer. Then we'll do 4 plus 2 is 6, and 2 plus 1 is 3. So you see how I kept them in the same exact columns, keeping like terms with each other, just dropping them down in the columns. That's it.